Thank you for joining us today as we explore the vital and evolving role of a geothermal technician. These professionals are key players in the renewable energy sector, responsible for installing, maintaining, and repairing geothermal systems that draw sustainable energy from the earth. As global energy demands shift toward greener solutions, the skills and knowledge of geothermal technicians have never been more critical. Today, we'll go through 10 essential questions often asked in interviews for this role. Each question is tailored to uncover a candidate's technical expertise, practical experience, problem-solving abilities, and dedication to safety and sustainability. Let's begin. 1. Can you describe your experience working with geothermal heating and cooling systems? When hiring a geothermal technician, one of the first things employers want to understand is your hands-on experience with geothermal systems. Geothermal heating and cooling systems, such as ground source heat pumps, are technically complex. This question allows the interviewer to assess your familiarity with installing vertical or horizontal loop systems, understanding how heat exchangers operate, or dealing with different soil types and their thermal conductivity. It's also a good opportunity to show whether you've worked on residential, commercial, or industrial systems. Mentioning specific projects you've contributed to, whether that's drilling boreholes, connecting loops, performing pressure tests, or integrating with HVAC controls, helps create a well-rounded impression. The interviewer will be listening for how long you've worked in the industry, the kind of training you've undergone, and how comfortable you are reading blueprints and following technical guidelines. Employers also appreciate technicians who understand both open-loop and closed-loop systems and who have troubleshooting experience. Your answer should reflect the depth and breadth of your work, as well as your ability to adapt to site-specific challenges. I have worked on various geothermal heating and cooling systems over the last 5 years, primarily installing and maintaining closed-loop vertical systems in residential settings. In these projects, I've handled drilling coordination, loop pipe installation, system flushing, and antifreeze charging. I'm also proficient in integrating geothermal systems with existing HVAC units, setting up thermostats, and conducting seasonal maintenance. I'm confident in interpreting system schematics and calculating loop field requirements based on property size and heat load. This hands-on experience has taught me how to handle different soil conditions, navigate local codes, and troubleshoot performance issues effectively. 2. How do you ensure safety during geothermal system installation and maintenance? Safety is a top priority in any construction or technical field, but it's particularly important in geothermal work due to drilling operations, heavy machinery, electrical components, and chemical fluids. This question gives insight into how a technician prioritizes safety in every phase of the job. A thorough answer should include compliance with OSHA standards, proper use of personal protective equipment, PPE, and steps taken during excavation and drilling to prevent underground utility damage. Candidates should mention performing hazard assessments, attending safety briefings, and staying updated on industry best practices. Employers will be interested in hearing how you handle chemical antifreeze safely, how you mitigate risks associated with trenching or confined space work, and whether you document incidents or near misses. It's also beneficial to discuss how you work as part of a team, communicate during complex operations, and shut down systems safely when required. Technicians who proactively identify hazards and take steps to minimize risk are highly valued. Be specific in your examples and procedures. I use appropriate PPE, including gloves, eye protection, and hard hats. When trenching or drilling, I follow all local guidelines and confirm underground utility locations using site surveys or calling utility marking services. I also double-check antifreeze handling protocols and electrical lockout-tagout procedures during maintenance. Communication and documentation are key to keeping every job safe and efficient. 3. What tools and equipment are you most familiar with when performing geothermal work? Geothermal technicians rely on a variety of tools and equipment, so this question helps gauge your technical know-how and versatility on the job. A strong answer will include hand tools such as pipe cutters and torque wrenches, as well as specialized equipment like thermal conductivity testers, flow meters, pressure gauges, flushing carts, and fusion welding tools. It's useful to highlight your experience with drill rigs if applicable, and whether you're comfortable working with control panels or programmable thermostats. Employers will also be impressed by technicians who can perform ground loop pressure tests, use digital multimeters, and operate HVAC diagnostic tools. This question also provides an opportunity to mention any certifications, like pipe fusion training or refrigerant handling. Demonstrating your familiarity with the full range of tools shows not only technical ability but also efficiency and readiness to tackle different project needs. I regularly use pipe fusion machines, flushing carts, and pressure testing equipment for geothermal installations. I'm comfortable with pipe cutters, torque wrenches, and thermal insulation tools. For diagnostics, I use multimeters, flow meters, and temperature probes. I've also worked with drilling contractors and understand the operation of drill rigs used for vertical loops. For integration with HVAC systems, I use manifold gauges, refrigerant scales, and sometimes smart thermostat programming tools. My knowledge of tools ensures I work quickly and accurately while following all safety standards. 4. How do you troubleshoot a malfunctioning geothermal system? A technician's ability to diagnose and resolve system issues quickly is essential. This question assesses your problem-solving process and technical understanding. Effective troubleshooting begins with identifying symptoms, such as poor heating/cooling output, abnormal system noise, or increased energy usage. You should mention checking for loop pressure drops, air in the lines, improper flow rates, thermostat errors, or pump failures. The interviewer wants to hear about your logical approach, how you isolate the issue step by step and verify each component. It's also important to communicate whether you use system logs or diagnostic tools and how you confirm your findings before replacing parts. The best answers will reflect both technical depth and a calm, methodical attitude. Showing that you can resolve issues while minimizing downtime demonstrates value to employers. They'll also be watching to see if you know when to escalate problems or consult with engineers. When troubleshooting, I start by listening to the customer's description of the issue, then check for error codes or signs of inefficiency. I examine loop pressure and temperature differentials to rule out flow issues. If needed, I inspect pumps, valves, and thermostats. I use a multimeter and flow meter to confirm electrical and mechanical function. I work through each system component methodically to identify the root cause. If refrigerant or compressor issues arise, I check for leaks and adjust accordingly. I make sure to test the system thoroughly before declaring it fixed. 5. What is your understanding of open-loop versus closed-loop geothermal systems? This question tests your technical foundation. A well-prepared candidate should confidently describe the differences between open-loop and closed-loop systems, including their design, operation, and applications. Open-loop systems draw water from a well or pond and discharge it after use, while closed-loop systems recirculate a heat transfer fluid through buried pipes. Each has pros and cons. Open-loop is often cheaper to install but may be limited by local water availability or environmental regulations, while closed-loop is more consistent but requires more excavation. Employers want to know that you understand which system best suits different climates, soil types, and property layouts. Discussing heat exchange efficiency, potential fouling in open loops, or antifreeze use in closed loops shows that you're well informed. You might also reference installation or maintenance differences, such as how you pressure test closed-loop systems or clean open-loop filters. Clear, accurate knowledge on this subject reinforces your credibility. Open-loop systems use groundwater as a direct heat source and discharge it after heat exchange, which can be efficient but depends on water quality and availability. Closed-loop systems circulate a mix of water and antifreeze through sealed underground pipes, making them more consistent and better for residential use where water discharge isn't possible. I've worked with both types. Closed loops require careful pressure testing and insulation. Open loops need regular cleaning to prevent mineral buildup. Knowing the benefits and limits of each helps guide installation choices. 6. How do you calculate the proper sizing and design for a geothermal system? Sizing a geothermal system correctly is essential to ensuring energy efficiency, comfort, and system longevity. This question assesses a technician's understanding of how to evaluate and design the right system for the space it will serve. A solid answer will reflect your familiarity with manual J-load calculations or similar methods used to estimate the heating and cooling needs of a building. Technicians should also discuss factors like square footage, insulation values, local climate data, and building orientation. It's important to mention how soil type and moisture content affect loop design, particularly in horizontal versus vertical installations. You may use tools like thermal conductivity testing to determine how much pipe is needed to meet energy demands. Discussing heat pump sizing and loop field layout is essential, as oversizing or undersizing can both cause operational issues. A well-prepared candidate will also know how to work with designers, engineers, or architects to interpret blueprints and incorporate geothermal into the overall energy plan. Being able to adapt design parameters based on real-world site conditions shows flexibility and depth of knowledge. I begin by performing a full load calculation to understand the building's heating and cooling needs. I consider factors like insulation, window types, occupancy, and local climate. Once I have the load, I evaluate the soil's thermal conductivity and moisture content to determine loop field design. I calculate required borehole depth for vertical loops or trench length for horizontal systems. I also ensure the heat pump matches the load for peak performance. Working with engineers, I adjust design specs based on actual site data to optimize system efficiency. 7. What steps do you take to maintain the efficiency of an operational geothermal system? Maintenance is key to keeping geothermal systems running efficiently for years. This question allows the interviewer to evaluate your approach to routine servicing and performance optimization. A strong response should demonstrate your knowledge of how to check and maintain both the ground loop and the heat pump. Mention tasks such as monitoring loop fluid pressure, checking antifreeze levels, cleaning air filters, and inspecting circulation pumps. You might also explain how you inspect electrical connections, thermostats, and system control settings to ensure they function correctly. Some technicians also perform flow and temperature checks to verify that the system is operating at optimal efficiency. It's helpful to mention the importance of flushing the system when needed or recharging antifreeze to maintain proper thermal transfer. Additionally, explain how you record service visits and communicate any recommendations for performance improvements to property owners. Regular maintenance not only prevents breakdowns, but also ensures energy savings and customer satisfaction. Showing that you approach maintenance proactively is a sign of professionalism and technical discipline. To maintain system efficiency, I regularly check loop pressure, fluid levels, and temperature differentials. I clean or replace air filters, inspect pumps and compressors, and verify electrical connections. I also confirm thermostat programming and look for signs of wear in moving parts. For closed-loop systems, I ensure antifreeze is at the correct concentration and top it up if needed. I log all readings and provide performance reports to customers. These steps help prevent system strain and keep operations smooth year-round. 8. Have you ever encountered a major installation challenge, and how did you resolve it? This question seeks to explore your problem-solving ability and how you perform under pressure. Real-world geothermal installations often involve unexpected challenges, such as hitting bedrock, dealing with limited space, or adjusting for weather delays. A strong response should walk the interviewer through a specific scenario, describing the issue, how you identified it, and the steps you took to resolve it. You'll want to focus on collaboration with team members or other contractors, clear communication, safety awareness, and staying within time or budget constraints. Technicians who remain calm and adaptable during difficult installations are highly valued. The interviewer also wants to see whether you take ownership of your role, think creatively, and make informed decisions based on site conditions. It's okay to mention a difficult situation, as long as your resolution was safe, effective, and professional. Sharing a challenge also demonstrates your experience and preparedness for future complications in the field. On one project, we hit unexpected bedrock while drilling for vertical loops, which halted progress. I worked with the drilling team to adjust borehole placement and confirmed the new layout with engineers. We also recalculated the loop lengths to maintain system capacity. I updated the client, adjusted our schedule, and managed deliveries to avoid downtime. The system was completed safely and on time. This experience taught me the importance of flexibility, teamwork, and real-time problem-solving in the field. 9. How do you stay informed about advancements in geothermal technology? Geothermal technology is constantly evolving, and technicians need to stay updated with new tools, regulations, and energy efficiency standards. This question helps determine whether you're committed to continuing education and professional growth. Your answer should include how you seek out new information, such as attending training seminars, subscribing to industry newsletters, or earning certifications. Mentioning memberships in professional organizations or participation in manufacturer-specific training programs can also strengthen your response. Candidates who are proactive about learning show initiative and are more likely to bring innovative solutions to their employers. Discussing awareness of newer heat pump technologies, eco-friendly antifreeze options, or smart integration tools, like Wi-Fi thermostats or energy monitoring systems, also demonstrates you're staying current. The interviewer will appreciate technicians who see their role not just as a job, but as a dynamic and evolving career. Adaptability and curiosity go hand in hand with technical competence in this industry. I stay informed by reading industry publications like Geo Outlook and attending manufacturer training sessions for updated equipment. I also participate in online webinars and follow geothermal associations for news on codes and best practices. Recently, I completed a certification on variable speed geothermal heat pumps. Staying current helps me apply the latest technology in the field, which benefits both efficiency and customer satisfaction. I enjoy learning and make it a priority to grow my skills as the industry evolves. 10. Why do you want to work as a geothermal technician, and what motivates you in this field? This final question touches on your personal motivation and long-term career goals. Employers want to understand what drives you and whether you're passionate about renewable energy, environmental sustainability, or hands-on technical work. A compelling answer may discuss how you enjoy solving mechanical problems, working outdoors, or contributing to cleaner energy systems. This is your opportunity to explain how geothermal work aligns with your values, skills, and interests. Perhaps you appreciate the stability of this growing sector or the technical variety it offers. Emphasizing your desire to help customers reduce their environmental impact or your satisfaction in building something sustainable from the ground up can make your answer stand out. Hiring managers look for technicians who see themselves growing within the industry, taking on more complex work, or mentoring others. A strong personal connection to the role often translates into higher job satisfaction, better performance, and greater loyalty to an organization. I enjoy hands-on technical work and the satisfaction of building systems that make a real environmental impact. Geothermal technology aligns with my values around sustainability and long-term energy solutions. I'm motivated by problem-solving and learning something new on each job. This field challenges me while allowing me to contribute to cleaner energy use. I see a long-term future in geothermal and hope to grow into more advanced roles where I can train others and help improve system designs. Geothermal technicians play a vital role in advancing clean energy. With strong technical skills and a passion for sustainability, they ensure efficient, reliable systems. This role offers long-term opportunities for growth while supporting a greener, more energy-efficient future.